Hello and welcome to our lesson on fluids and non-fluids, where we look at the property of a fluid. So, our objectives today. We want to define what is a fluid, but we also want to explore different types of fluids, things that can become or exist as fluids. So, firstly, the states of matter. When we say a state of matter, we're talking about the way something is at a given moment. It's not the way it'll always be, but it is the way it is currently behaving. We have solids, liquids, and gases. Solids are defined by matter that is packed closely together. Liquids are spread out and can move, and gases are spread out a lot more and are incredibly light. Their volume is very low. So, or density, their density is very low, which takes us to the states of matter. And this is looking back at the particle theory of matter. And the particle theory of matter states that when particles or molecules, like inside this diagram, receive energy like heat, they can spread apart. So when something is cold, that is the absence of heat or the absence of energy. So the molecules pack closely together. As they gain heat, they're able to spread apart and become a liquid. As they gain more heat, they spread apart more and they become a vapor or a gas. So this is something we've already covered. Technically, any type of material subjected to enough heat can turn into a gas. And a liquid. So when we talk about fluids, we're taking it one step further. A liquid and a gas can both be fluids. And there's a reason why. Because there are these essential properties. A fluid can be poured. And when I say poured, you pour it, it doesn't create a pile. So if you're pouring sand, yes, the sand can be poured, but inevitably you'll end up with kind of a ridge or a pile, like in an egg timer. So sand isn't a fluid. It's fluid-like, but it is not a fluid. It takes the shape of its container. It can flow, and it can maintain its volume. So regardless of where I pour a fluid, I always have the same amount of it. If I pour a fluid into a container that's shaped like a rubber glove, it'll be the shape of the rubber glove, but it'll still have the same amount of fluid or the same volume. If I pour a fluid into this bottle, I'll always have the same amount of that fluid, except it'll be the shape of this bottle. So those are the essential properties. Which brings us to our first shout out. Pause the video and take a moment to define a fluid. If you said that a fluid is or can be poured, takes the shape of its container, flows, and maintains its volume, you would be correct. And this takes us to our final step, your homework. Looking at these three things, I want you to explain, is it a fluid or when can it be a fluid? And that concludes our lesson.